Greetings, M Squared here. Today we are going to talk about the quadratic formula. This is our final way to solve quadratic equations. So we've learned, this is our fifth way, we've learned to solve quadratic equations by graphing, by factoring, by taking the square roots, and by completing the square. And today we're going to talk about using the quadratic formula. So this video is just how to use the quadratic formula to determine how many x-intercepts or roots you have. So next video we will solve. So this is just about the discriminant, which is what's underneath the square root sign of the quadratic formula, and finding a, b, and c. So this is one of our learning targets. So you need to memorize the quadratic formula. We have a little song for that. And then we have to find the discriminant. And then the next learning target is solving. So this is our final way. All right, so I have a little song. I'm going to sing it to you, because we have to memorize this, and music is really powerful and it gets in our brain, so we're going to sing this a lot in class. But it goes, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's my little song, so make sure you sing it lots or listen to it lots. And now we're going to talk about the different parts. So we see the 2a. We've been doing negative b over 2a for a while, so that should look familiar. We've been doing the plus or minus. We've got this b squared minus 4ac now underneath the radical. In class, I'm going to show you how you derive that from standard form, but just know you have to memorize that, and it comes in super, super handy from here on out in math. So you need to know what part the discriminant is, because in this learning target you have to find the discriminant and then you have to tell what kind of roots there are using the discriminant. So you'll see here b squared minus 4ac is in each of these. If b squared minus 4ac, if after you find that it's greater than 0, that means it's positive, and it's not a perfect square. Remember, we've talked about perfect squares before: 4, 9, 16, 36, 49, those kind of things. If it's not a perfect square, then you have two real irrational roots. So here's an example. We have a is 3, b is 5, c is negative 4. Now, in a real problem, you want to watch out. If it's not in standard form, you might have to move things from one side to find your a, b, and c. It's not just whatever's in front of x if x is on the opposite side of x squared. So make sure you're careful and get it in standard form before you find your a, b, and c. So we're going to find b squared minus 4ac, because my discriminant is b squared minus 4ac. So b squared minus 4 times a times c. So that's 25. And then probably want a calculator here. 12 times 4, I believe that's 48. And it's a negative times a negative. So that's a plus, because our two negatives are going to kind of cancel there, because a negative times a negative is a positive. Zoom in a little. And now we are going to add 25 and 48, so that's 73, I believe. And notice it's positive, and it's not a perfect square. And so that means I have two real irrational x-intercepts, or roots, or zeros. Remember, there's different words. Here they're calling them roots, but we also call them x-intercepts, or zeros, or solutions. So that's an example of two irrational roots. And now we're going to talk about two real rational roots. So if it's greater than, the discriminant is greater than 0 and it's a perfect square, then there's two real rational roots. So again, a is what's in front of x squared, b is what's in front of x, c is the constant. So we're going to take b squared, my discriminant equals b squared minus 4 times a times c. So again, my negatives cancel out, and I'm left with 64 plus, that's 20 times 4, that's 80, and that's 144. That's a perfect square. The square root of that is 12. So now I know I have two real rational roots. I'm actually going to be able to take the square root of that and then add it to my other stuff in the formula. So it's going to turn out nice and pretty. The irrational ones, you've got to use a decimal approximation. Okay, so now we're going to talk about, hey, what happens when the discriminant is equal to 0. So here's an example. A is 1. Remember, if there's no coefficient that you can see in front of the x squared or the x, then it's just 1, because it's talking about one of those. So that's negative 6 for b and 9 for c. So again, discriminant equals b squared. Now if it's negative, make sure you put it in parentheses, especially if you're using your calculator, because it might give you the wrong answer depending on your calculator. So it's negative 6 that's squared, not just the 6 that's squared. So b squared minus 4 times a times c So that's 36 minus 36, which gets us a big 0, which means I have one real root. That's the kind that just x-intercept, no, the parabola just, here's our x-axis, it just hits the x-axis and goes back up. That's the kind, when you get a discriminant of 0, you know it just touches the x-intercept and then, the x-axis, sorry, and goes back up. Okay, last one. What happens if it's less than 0? Well, then we have no real roots. So let's talk about that. We have a 1 for A, a -2 for B, and a 4 for C. So we get B squared equals, discriminant equals, okay, we'll go again. Discriminant equals B squared, so we put that in parentheses since it's negative, minus 4 times A times C. So that's 4 minus 16, which is a -12. And that means we have no real roots or no x-intercepts. That's the kind that doesn't even hit the x-axis. It'll be up there somewhere. And the reason for that is because when you remember our formula, the b squared minus 4ac is underneath the radical sign. And if you take and put a -12 underneath the radical sign, it gives you an error. Because there's no way to have a number times itself that equals a negative number. So that's why that is no real roots. Okay, so that was an example of each, but now I'm not telling you which one it is. We're just going to figure it out. So it might be easiest to use your calculator. So the discriminant is b squared minus 4 times A times C. Sometimes I just put it all in my calculator, but remember, if you're going to use your calculator, you have to put in, especially this kind of calculator, you have to put a parentheses around the negative. So I'm going to put parentheses -9 squared minus 4 times 3 times -16. I get 273. Well, 273 is greater than 0 and not a perfect square. That means I have two real irrational roots. That's what I have there. Okay, we're going to try this one. Notice it's not in standard form. I have to subtract 5 from both sides. So that means C is going to end up being -6. And A is -8 and B is -3. So I'm going to do B squared minus 4 times A times C. So I get 9, and do you see how two negatives cancel out? And that's going to be a negative. So sometimes what I do, if I'm just trying to find the roots, is I'm like, oh, that's definitely not going to be a real root, because I know it's going to be negative. But if they're asking me for my discriminant, I need to go ahead and find it. So I'm going to say 9, because that was 3 squared, minus, because one of them is negative, and then I'm just going to multiply, because I got rid of the negatives there, and then I don't have to worry about it. Just put 1 in there. -183. That's the whole thing. So -183 is my discriminant, and that gives me no real roots. And this is Algebra 1, and so in Algebra 2 you learn about what kind of numbers those are. But for Algebra 1 we say those are no real roots. It's not possible. And then later it becomes kind of possible when you learn about complex numbers. But for this one, we don't know about those yet. Okay, b squared minus 4 times A times C. So that's 400, and 20 times 20 is also 400. So we're getting a 0 for our discriminant, which means we have one real, rational root. And that is how you use the discriminant to determine the number of roots and the kind of root. So good luck with that. M squared, signing out.